So let's continue. 5.3 statistical analysis for two population mean, but for this time dependent cases. How you want to know your sample is dependent? So recall back our confidence interval. How you want to know that our sample is dependent? First, your sample must have before and after data. So means that you have paired data. Okay, number 2, that sample or that data came from the same object. And number 3, they must have same sample size. And then your data is dependent, you will have capital D. Dependent cases. 5 runners were randomly selected to determine if there is a difference in the amount of calories burned per minute between running outdoor and running indoor. So dia nak tengok runner ni, kalau dia running outdoor, calories burn dia berapa, and then kalau dia running indoor, calories burn dia berapa. Adakah amount calories tu sama ataupun tidak? So is there any difference? Okay, each runner was asked to do the outdoor and indoor running of the same duration but on 2 different days. So results, amount of calories burned per minute were recorded as follows. We have 1, 2, 3, 4, 5 runners. So the same runners here. So let's say runner number 1 running outdoor. Today they get data for outdoor calories burned, and then tomorrow running indoor they get data for calories burned. So this data came from the same object, came from the same person. So this one is dependent sample. So for dependent sample, you will have mu capital D, where the D is the difference between two data. Right. So assuming normal population test at alpha 0.06, whether outdoor running and the indoor running give on average the same result, equal, same, right? So what is your H null and H1? H null, H1, because of the same. So for a dependent sample, it start with mu capital D, mu capital D, because of the dependent sample. So the symbol is same, equals to 0, not equals to 0, where the D is equals to outdoor minus indoor, outdoor minus indoor. Okay, let's calculate the D. Outdoor minus indoor. 14 minus 12, 2. 15 minus 11, 4. 13 minus 12, 16 minus 10, 14 minus 10. You got this new data, D. So this new data, later on, we will use to find the X bar D and the S D. So we recall back our confidence intervals, the same concept. So this one is step number 1. So what is your step number 2? Step number 2, test statistic formula. So which formula you want to use? Test statistic. So look at here. Can we use formula number 1? Cannot, because sigma square is not given. So you cannot use here. Hypothesis testing mu D. Can we use formula number 2? Cannot, because our n is equals to 5. So you cannot use this one. So the formula is t-test here, where the nu is n minus 1. So the formula is t-test is equals to X bar D minus mu naught over SD over square root n. So let's look at here. Do we have the X bar D? No. You have to find X bar D from this data. Substitute this data 24164 into your calculator and then get the x bar. So the x bar here is equals to 3.4 and the SD is equals to 1.9494. So now we have the x bar D, we have the SD, n equals to 5, mu naught here, mu naught equals to 0. So substitute 3.4 minus 0 over 1.9494 over square root 5. You will get 3.9. This is your t-test. Step number 3. One tail or two tail. Symbol is this one. So, two tail. Two tail. Two shaded region, negative and positive. So, T alpha over 2, no, T 0.06 over 3 and minus 1, 5 minus 1. So, T 0.034 is equals to 2.6008. You put here 2.6008, here is negative 2.6008. Right. Step number 4. Reject or accept H null? Reject or accept H null? Your t-test is 3.9. So where 3.9 is located? Is it here, here, or here? 3.9 is greater than 2.6. So 3.9 is here, is in the shaded region. So it's in the rejection region. So since t-test 3.9 is greater than t 0.034, 2.6008, reject H null. So what happens if you reject H null? You reject this H null. Means that mu capital D not equals to 0. So running indoor or running outdoor will not give you the same amount of calories burn. So kalau you running indoor, calories burn dia lain. Kalau you running outdoor, calories dia pun lain. So your conclusion, at alpha 0.06, there is not enough evidence to support claim that amount of calories burned outdoor and indoor is similar. So maksudnya dia berbeza.